Hello, today's topic is literal equations. Let's start with the definition. A literal equation is an equation in which the variables represent specific measures. Commonly, literal equations are called formulas. For example, the very common formula, area equals base times height. Instead of writing it using the words, we would write it using letters. For example, A equals B times H. Can you think of other formulas that you have experienced or used in science or art or shop classes? A very important literal equation in algebra is the linear function literal equation. And I'm sure you've seen this before, y equals mx plus b, where m is measuring the slope and b is measuring where the coordinate is on the y-axis. This equation, I don't know if you knew it, has two names. You are probably familiar with it being called slope y-intercept, but it is also called the general form of linear equations. We also have a general form for quadratic equations, which looks like y equals ax squared plus bx plus c. So this is where the general form of a linear equation. Two different names representing the same formula. We can rearrange the order of variables in a literal equation by using the equality properties that we used to solve equations in our past classes. For example, if you were asked to solve 12x equals 36, you would apply the division property by dividing by 12 and then finding that x equals 3. Remember, there's like a 1 right here because 12 divided by 12 is 1. We could also take that 3 for x, and we could use substitution to check our work and see if we have the correct value. So in this case, this equation had one solution, x equals 3. Take our formula that we saw at the beginning of this video. Area equals base times height. You'll notice there are no numbers, and that is the area for a rectangle. So if you had a rectangle, you would have the base and you would have the height. And if you wanted to find out, for example, how much carpet to put on there, well, you might know the amount of feet that are the height and the amount of feet that is the base. But if you don't, instead of putting numbers in, you would just use the letters. And then let's say, though, you knew the area you knew the area in the base and you wanted to find the height. So you could isolate the height by dividing both sides by b. So you can find the height of a rectangle if you knew the area and you divided by the base. So the height of a rectangle would be area divided by base. Let's take another common formula that you've probably seen, circumference of a circle. The circumference of a circle equals 2 times pi times the radius. And if we were asked to find the radius, we would want to rearrange the variables and isolate the radius to get it by itself. Well, if we look at the radius, we notice on the right side with it is 2 pi. This is why we would divide both sides by 2 pi, applying the division property again, in order to find that radius equals circumference divided by 2 times pi. Let's look at the perimeter of a rectangle. The perimeter formula for a rectangle is P equals 2 times the base plus 2 times the height. And let's just say that we wanted to solve this for the length. Now you will notice that sometimes the perimeter formula, instead of using base and height, they use length and width. Once again, you can see how in mathematics, depending on what text you're reading or who you're talking to or how a problem is presented, you have two formulas that look different, but they are the same thing for the same situation, the perimeter of the rectangle. So if I wanted to solve my perimeter formula for a rectangle to find the length, I would start rearranging the letters by applying the equality properties. So first I use the subtraction property, and then I use the division property, and you'll see I have the length isolated, and I've rearranged the other variables so that I have perimeter minus 2 times the width divided by 2 will equal the length. And then I would leave the problem like this. It is possible that this problem, though, could be separated into P over 2 plus negative 2W over 2. Which could then be written as the 2's would cancel out and we would have a negative sign still left over. Because you would have like negative 2 divided by positive 2 to leave a negative 1W. Let's go back to our y equals mx plus b. And if we were asked to solve for b, to find the y-intercept, well, we would rearrange using the subtraction property. Subtracting minus mx from both sides will leave us with b equal to y minus m times x. Are you familiar with the temperature formula where we take Celsius and we can find how much temperature in Celsius is if we know the Fahrenheit temperature? This formula will tell us Celsius temperature if we know Fahrenheit. What if we know Celsius and we seek Fahrenheit? In this case, we'd have to solve for F. Well, in this case, I have the fraction 5/9, which does complicate things a little bit. So we can make this formula a little bit easier to solve if we go ahead and rewrite it with the 5/9, the 5 in the numerator and the 9 in the denominator. What equality property would you apply to begin this problem? Well, if you said multiply both sides by 9, then that would be a good start. By multiplying both sides by 9, what we end up doing is we get the 9 from the denominator to cancel, so we are left with 9c equals 5 times parentheses Fahrenheit minus 32. And then we would apply that division property in order to cancel the 5's. So now we have Fahrenheit minus 32 equals 9/5 times C for Celsius. Remember, we are trying to solve for Fahrenheit. So there would be one more step where we would use the addition property. And finally, with the addition property, we have Fahrenheit equals 9/5 Celsius plus 32. This formula would tell us Fahrenheit if we knew Celsius. Are you familiar with E equals mc squared? This formula is from physics. It's Einstein's famous formula for energy. Energy equals mass times the speed of light squared. This formula was used to better understand nuclear fission reactions. It is called the mass-energy equivalence formula. If we were asked to solve E equals mc squared for m, we would apply the division property to find that mass will equal energy divided by the speed of light squared. I hope you found this video helpful, and remember, math is experience-based. So the more math you experience, the more your understanding will grow, and you'll be able to solve problems using mathematics